Me too. I'm forever doing these things twice. Now, this video will be interesting for anybody into ham radio or just trying to understand what they call coax, feeders, balance line, ladder line. I'm also aiming it at people doing the foundation exam. But, chill out. Stay with me on this. I'm on page 12 of the foundation book. But there is, if you've got a ham radio station, a little ham radio, in your shack, they call it a shack, right? Normally it's in a luxury room, or a bedroom, or in my case, we've got the bunker here, which is the back of the garage, which I converted. And then you've got an antenna out in the backyard, out in the field, out in the garden. You need to get the energy from the back of your radio to the antenna. There's only really two ways of doing that, unless you've got, a bit of magic. But there is only two ways. The first way, I'm trying to find a pen that isn't too bleedy. I think I've thrown them away. I'll use this one anyway. So we'll go on this page here. So there's only two ways. There's something called coax, which is what went in the back of your TV in the old days. I never thought I'd say that. Coax, and it has a centre. It's a piece of cable. It's got a centre, and then it's got some braid on the outside, which we call a shield. Now, they've drawn us a couple of pictures here, coax, on there, and that's fine. And what happens is, basically the RF travels on the pin here, and we've got the braid here supplying the other half. Right, and then you have something called balance line, which is take the pin and put it here, and take the braid and put it here. And very often you've got something called ladder line, and because it looks like a ladder. And they've got a picture here of ladder line. There it is there. Two twin wire feeders with different separations. The thick stuff is called 450 ohm. Just what they call it. Coax has something called an impedance, which I don't need to tell you exactly what that is at the foundation, but all you need to know that it's 50 ohms, okay? Could be 50 bananas, but it's 50 ohms, right? And that's the coax. And it also, coax has loss. Now, I did a video about loss and how to choose your coax, all right? And that'd be quite interesting to go and watch after this one here. So we've got loss, we've got less loss on a balance line. But balance line is a little bit difficult to use. Not many people use it. But on the back, for instance, of, I'm looking at Elecraft K4 there. If you look at a rear panel of, I've got an AT4K. It's something called a balanced tuner, all right? And here is a picture of the rear panel, and you can see it says balanced out. So we got a couple of, we'll put either ring terminals or fork connectors on these, and it connects to here, all right? It's a little bit difficult because you've got to keep balance line away from metal objects. Some people find it difficult getting it through walls. It can't really lie on the ground, and there's a few things, whereas coax, you can higgledy-piggledy anywhere, but coax has got more loss. And also on the balance line, it's got less loss, all right? A lot less loss. However, you do need a fancy piece of machinery, or at least some sort of what they call AMU or ATU, an antenna tuning unit, to be able to cope with the balance feeder. To be honest, I really wonder why we put it in the syllabus at this level, because most of the time we're using coax. It's reminding us here on this little chart that because on a balance feeder, the AC, the alternating current RF, goes like this in like matched. What happened is to completely balance. They each cancel each other out. So they get to the antenna, but they don't radiate. Fascinating. Whereas, frankly, neither should good coax radiate either. But we'll be doing electromagnetic compatibility and balance and chokes and all sorts of other things I'm only saying this so the experts watching this go, you missed a bit out there. And we got connectors. So the average HF set, high frequency, shortwave, all right, the long distance skip hoppy stuff, is normally got something called an SO239 on the back of it, and that's an SO239 there. Therefore, to attach a socket to that, we need a PL259. Most of the time, a PL259, it kind of looks like this one here, is adequate, right up to a good one, right? Because there are really crappy PL259s and most exceptional PL259s. So you just need to be careful when you buy. I'm not going to do a plug for anybody, but bearing in mind, if you just did, let's just have a different quality. There we are. So here is a PL259 from a company called Messi and Poloni. It's just very well engineered. And up to VHF, you won't be able to tell the difference, okay? It's actually a shielded banana plug. Interesting enough, it's called a banana plug because, you know, I've got my banana ruler here, but it really is called a banana plug. If you want to know what a banana plug looks like, a banana plug looks like this. I don't know why they call it a banana plug, because it's not in the shape of a banana. Anyway, we've got PL259s. Then we have something called NTypes, which on the surface look very much like a PL259. However, it's not. It's got a thinner pin. In fact, Wikipedia have got a good article. It's got a little thin pin here, and it's got some nice shielding. And a good N-type is better than a good PL259, but getting hold of a good N-type is difficult. Jim, W6LG, did an experiment most recently with that, and in the end he said you might as well just stick with a PL259. So we've got PL259s, N-types, BNC connector, sort of thing you might have on some test equipment, or maybe a handheld, but you can see what it looks like here. Oh, there's a Messi and Poloni BNC connector. Sometimes difficult to fit, although that one looks very good. Actually very easy to fit. We'll do fitting plugs another day. And then SMA. You've probably seen an SMA connector before. The only thing you've got to watch out with an SMA connector is sometimes you've got a male with a female interior, or you've got a male with a male interior. There's all sorts of, look, there's one with its male insert. There's another one without. You can't screw this one here to this one here. So whatever, you just need to be careful. But a lot of, little walkie-talkie. Oh, I've got one over here. That's actually for a Wi-Fi point, but that is, I don't know what they call it. It's a kind of a male with a female insert. Very odd. And then the microwave boys, they get into something called a waveguide. That's all you need to know. Instead of using coax, they squirt the RF up the tube, basically, and it just goes up the tube. Right, next video we're doing antennas, and I like antennas, so we'll cover that. That is the syllabus for the foundation, and if you didn't know anything about coax or feeders, maybe you know a tiny bit now. All right, have a nice day. See you later. All the best. Bye.